Okay, let's do the next few problems in the graphing. So in number 3, we have to graph this rational function. So let's first of all take a look at its degree. We know that its numerator is 1 more than the denominator. So that is improper. Therefore, it will have a slant asymptote. So I'm going to start with the vertical asymptote, which is going to be right here at the 0 of the denominator, which is going to be x is equal to 2. I'm going to go ahead and graph that real quick. And let's see, we could get to the, I'll do the horizontal or slant asymptote right now. So remember, if you're getting a slant asymptote, you have to divide the rational function. So I'm going to do that right here. So we're going to have x minus 2 and I'm pretty confident with our division, so I'm just going to go ahead and do that. Okay, so once I get about this far, I usually just stop. I know that there's a remainder here, okay? But the only part of this that really matters for what we're doing right now is that part, not the remainder part, because that remainder part is the equation of the slant asymptote. So I'm going to go ahead and graph that. Okay, it's going to have a slant asymptote right there. And remember, the remainder is just the vertical asymptote, but we already knew that from the beginning, which is why I usually just stop right there once I get the slant asymptote. Okay, the intercepts. So for the y-intercept, I need to make x equal to 0. So that would give me 0, that would give me 0, and I would have 2 over negative 2. So when x is equal to 0, y is equal to 2 over negative 2, which is negative 1. And there's my y-intercept. X-intercept's not quite so easy, and I'm going to need some room to do it, okay? So I'm going to erase everything up here, including the division, which is another nice part about doing this on Chromebooks, is that you don't really run out of space. So my x-intercepts, remember, are the zeros of the numerator. So I start this out by trying to factor with a equal to 1, and I quickly discover that there's nothing in the, shouldn't say that there's no whole numbers in the world that multiply to 2 and add to negative 6. That doesn't mean that it doesn't have real roots, though. So what's another way that we can think of to discover the roots? I can use the quadratic formula. So I'd essentially have 36 minus 8 over 2, which would give me the square root of 28 over 2, which would then give me 6 plus or minus, well, the square root of 28, remember, would break down to 7 times 4. The square root of 4 is 2, so 2 times the square root of 7 over 2. And then 6 divided by 2 is 3, plus or minus the square root of 7, because 2 divided by 2, this divides to 3, and then this divides to 1. So here are my x-intercepts. So you could write, I think this is what it says in the answer key, 3 plus or minus the square root of 7, comma, 0. And those are my x-intercepts. But now when I go to make those dots on the graph, it gets a little tricky. So I'm actually also okay with you just writing the answer as a decimal. So 3 plus or minus the square root of 7. So I would have 3 plus the square root of 7. 3 minus the square root of 7. So it gives me 5.65 and 0.35. 5.65. So another acceptable answer up there would have been 5.65, 0, and 0.35, 0. So that tells me that the roots are right here at 5.65 and 0.35. Let me make sure that those are the numbers that we got in the calculator. I think they were 5.65 and 0.35. Yes, that is them. So now that we have those three things graphed, that is what you would be graded on. But just to be sure, we check it in Desmos and then draw the shape of the graph. So we have, let's make sure I can remember it, x squared. I might have to look back. X squared, was it minus 6x plus 4? It looks like it, because let's see. X squared minus 6x, oh, plus 2. Okay, that one was close. Plus 2, and this should be 5.65, and that should be 0.35. Yeah, that's definitely it. And then remember, all of that was divided by the denominator of x minus 2. And when I put x minus 2 in parentheses, or as the denominator, I should say, this is what I get right there. And that is what our graph would look like. Okay, and I could quickly put in our asymptote of x minus 4. And there it is. That is number 3.